Hello everyone. We were discussing about the chapter units and measurements. So we have done almost all the topics. Now let's discuss few more problems from the exercise part. So let's discuss this question, exercise 2.13. So you can read the question now. A physical quantity is given the P is equal to A cube B square divided by root C into D. So A, B, C, D are some physical quantities. The percentage errors of this measurement in A, B, C and D are given. 1%, 3%, 4%, 2% respectively. What is the question is asking for? Calculate the percentage error, the total percentage error in the physical quantity P. Okay. And one more question is given here. Calculated value of this physical quantity is given. What is the value given? P is equal to 3.763. And the question is asking for to what value you should round off the result. So we have already discussed about the round off. So let's do this problem here. What is the percentage error in P? So we can write this formula as delta P divided by P into 100. This is the formula we have learned, the percentage error in a given physical quantity, which is equal to, now A cube. So we can write here what? 3 times delta A divided by A into 100. Now what is next physical quantity? B. So we have to write here 2 times delta B by B into 100. The percentage error is given in the question. Now divide by root C. Root C means what? C to the power 1 by 2. So we can write here plus, we are adding all the errors, right? So 1 by 2 into delta C divided by C into 100 plus D now. What is the D to the power? Only 1. So we can write here delta D divided by D into 100. So let me tell you here what is delta P by P into 100. That is a percentage error in the physical quantity P. Delta A by A into 100, that is a percentage error in A. This delta B by B into 100 is a percentage error in B. And C, delta C by C is called what? Percentage error in C. And the delta D by D into 100 is a percentage error in the measurement of D. Now the values are given. So what is the total percentage error in the physical quantity P? 3 times, what is the percentage error in A? That is 1% plus 2 times, what is the percentage error in B? 3%. So 3% plus half into, what is the percentage error in C? That is 4% plus what is the percentage error in D? That is 2%. So what is the final answer? This is 3. So this is equal to 3 plus 6% plus 2%. This will cancel 2 and plus 2%. So what is the final answer here? That is answer become 13% is the error in a physical quantity called what? P. So what is the relative error in this case? 13 divided by, this is 13%, right? So 13 by 100, that is equal to 0.13. So what is the relative error here? 0.13. Now there is one more question in this one. Calculated value of P is given the 3.763. And to what value you should round off the result? So round off means what? You can see the relative error is here 0.13. 0.13 means how many significant figures are here? Only 2 significant figures. That means in your answer, there should be only what? 2 significant figures. So if you write the 2 significant figures here, you can write the 3 point, one more digit will come. Can we write 7 here? No. The dropping digit is what? 6, more than 5. So you can add what? 1 with the preceding number. So the answer become what? 3.8. Right? So this is the exercise question 2.13. Now let's do the exercise question 2.14. So you can refer your NCERT. Let me read the question for you. A book with many printing errors contains 4 different formulas. These are the 4 different formulas are given here. For the displacement y. So y is displacement of a particle undergoing a certain periodic motion. Okay, so this is a given, a particle is undergoing a periodic motion and the displacement formulas are given there. 4 formulas are given there. In bracket it is given the A is the maximum displacement. In an oscillation or a periodic motion, A is the maximum displacement. V is the speed, here V is given there, that is the speed of the particle, and capital letter T is the time period, and small t, of course, it is a time. Rule out the wrong formulas on the dimensional ground. So what we have to prove here? On the dimensional ground, we have to prove that whether the given equation is correct or not. So how to prove whether the equation is dimensionally correct or not? We have already discussed that one. That is, dimensions on the left hand side and dimensions on the right hand side must be what? Equal. So let's do the first one here. If you do the first one, the A, what is the dimensions on LHS? No doubt y is called what? Displacement. It is given the y is a displacement. So the dimensional formula on the left hand side is L. So I can write here in square bracket, talking about the first one. Alright, now right hand side, what is the right hand side is given the A, sine 2 pi t by t. A is the maximum displacement, so that is also displacement, so we can write the dimension as L. Next part you see sine, some values given there. Sine or cosine or whatever it is, this is an angle, right? What is the angle dimension? What is angle dimension? You have already learned that one. Theta is equal to arc length divided by radius. What is the dimension? Is there any dimension is there for angle? No, there is no dimension. So sine of some value, there won't be any dimension. So it must be what? Dimensionless, because this is an angle. So if you see this one, 2 pi t by t, t is the total time or time, capital letter T is the time period. What is meant by time period? Time taken to complete one periodic motion. Whatever it is, numerator it is time and denominator it is also time. So there is no unit inside the bracket. And don't bother about the 2 pi, that is a dimensionless constant is. So LHS is equal to L and RHS is equal to also L. So what we can prove here? The first equation is dimensionally correct. Dimensionally correct. So once again, theta, what is the dimension? There is no dimension. It is a dimensionless quantity. Okay. Now let's do the second. Y is equal to A sin Vt. A sin Vt. V is a speed and T is a time. Y, what is the dimension of Y? Displacement on left hand side. It is L, which is equal to A. A is also displacement. So right hand side I can write here L. Next one, sine, what is inside the bracket? V into T. What is the V? Speed. Speed dimension is what? L t to the power minus 1 into time is again T. That means you can see here T will cancel. But L is coming inside the sine. That means it is an angle. It should be what? Dimensionless. So this equation is wrong. So LHS is L, RHS is L into sine of one dimension. So this is wrong one. This is angle theta. Okay. So second equation is wrong. Now look at the third one. I think no need to do that one because Y, LHS is what? Displacement, Y. Now RHS is what? Displacement by time. That means definitely you can see here it is not L, it is coming. And moreover, you just check inside the bracket sine of angle. Sine of angle means what? The angle must be dimensionless. Here time divided by displacement. Some dimension is coming. So this equation is also wrong. Okay. Now look at the last case. So first of all, you check the sine and cosine value. If it is dimension is coming there, So no need to do that one, that is equation is wrong. But here sine 2 pi t by t, t means dimension is t, time period is also dimension is t, so t will cancel, so sine of no dimension is coming there. So this part is correct. Cos 2 pi t by t, that means here there is also no unit is coming or there is no dimension is coming, so this is also correct. Now look at these two cases, y and a root 2. What is a y? Displacement. Displacement LHS, we can write the dimension is L, which is equal to. Now what is a RHS here? RHS is A. A is also displacement. So that is also equal to L. And don't bother about the root 2, that is a dimensionless constant. So this equation is also dimensionally correct. So which all the equations are dimensionally correct here? A and D. Remaining two are wrong because it is not coming, or we cannot prove the principle of homogeneity. I hope it is clear. Now let's discuss the exercise question 2.15. So you can refer your Ncert physics book. So let me read this question for you. A famous relation in physics relates moving mass m to the rest mass m0. So this is a moving mass m and this is the m0 is the rest mass of a particle in terms of its speed v and the speed of light c. So v is the speed of that particle and c is the speed of light, that is in the question given. This is actually the relation of special relativity or special theory of relativity by Albert Einstein. A boy recalls the relation almost correctly but forgets where to put the constant c. So he didn't put the constant c here and he wrote the equation wrong. So what is the question here? Where he should put the c value. C means what? Speed of light. What is v means? The object is moving with a velocity v. So now to prove this equation whether it is dimensionally correct or not, you have to check the homogeneity principle or principle of homogeneity you have to apply. What is the principle of homogeneity? The dimensions on LHS must be equal to dimensions on RHS. So what is the dimensions on LHS? LHS, it is given their mass. What mass? When the object is moving with a velocity v, the mass is given there. So you can see here the dimensions on LHS is given their mass. So we can write it as capital letter M, that is a dimension of the mass, which is equal to, next one, m0 means what? Rest mass. What is meant by rest mass? The object when it is not in motion, and that mass is called what? Rest mass. That is also mass. So what is the dimension of m0 here? That is also equal to m. That means now the dimension is equal, but denominator is the 1 minus v square all to the power 1 by 2. So definitely you can see here 1 minus v square. Can you subtract a quantity 1? 1 means what? Dimensionless quantity. V square means what? There is a dimension is there. Can you subtract these two quantities? This term should be dimensionless. That means we can write here 1 minus v square. How you can make it is dimensionless? V means what? Speed, right? So below it also must be what? Speed. So here it is speed square. So divide by one is what is missing there? The speed of light, that is c square. Now you see what is the dimension on this v square by c square. It becomes once again dimensionless. So now you can subtract because this is also dimensionless. This is also dimensionless. So this portion is now over. There is no dimension on the denominator side. Now look at the left hand side, it is the mass m, and the right hand side m0 is also mass m. So what is a new equation? What is the actually correct equation it become? M is equal to m0 divided by, this is small m, m0 divided by 1 minus v square divided by c square all to the power 1 by 2. So according to Einstein's theory of relativity, what is the meaning? Just an example. This is a mass. This is having a mass m. So I say it as rest mass, that is m0. Just imagine this body is now in motion. I'm not throwing, just imagine the body is with very high speed it is moving. Imagine the speed of this particle is nearly speed of light or approximately speed of light. What will happen? B square and C square become what now? Equal, almost equal. If it is almost equal, the value become what? 1. 1 by 1. 1 minus 1, 0. So the answer become what? If the V and C are equal, we will be getting the m0 divided by 0. So what is the answer become? The moving mass equal to 1 by 0 means what? Infinity. So what is the mass? Infinity. This is called special theory of relativity. That means this mass m0 is moving with the speed of light nearly. Its mass become what? Infinity. So that is a part here. But now what we have proved here, this is the correct equation. So the student or the person, you forget to put the c square in this case. So I hope it is clear. Now let's do the question. Exercise question 2.16. So let me read the question. You can also read the question. The size of the hydrogen atom is about 0.5 angstrom. Size. That means it is given the radius of hydrogen atom is given the R is equal to 0.5 angstrom. What is meant by 1 angstrom? 1 angstrom is equal to, that is 0.5 into 10 to the power minus 10 meter. This is an SI unit, right? 1 angstrom is equal to 10 to the power minus 10 meter, right? So radius is given, the size of the hydrogen atom is given the 0.5 angstrom. What is the total atomic volume in meter cube? Total atomic volume in meter cube of a mole of hydrogen atom. 1 mole of hydrogen atom. Okay. So radius of the hydrogen atom is given there. So what is the volume of 1 hydrogen atom? Volume of 1 hydrogen atom is equal to, as you already learned in chemistry, as well as in physics, the size or the shape of the atom is what? Spherical in shape, right? So volume is equal to what? 4 by 3 pi r cube. This is the volume of 1 hydrogen atom. Okay. Now, how many atoms are there, or total number of atoms in 1 mole? That means number of atoms in 1 mole is equal to what? You have learned that one. That is called what? Avogadro number. What is that? Avogadro number. What is Avogadro number? Na is equal to 6.023 into 10 to the power 23. So number of atoms in 1 mole is equal to 1 Avogadro number, and volume of 1 hydrogen atom is equal to 4 by 3 pi into r cube. R is already given there. So now the question is asking for what is the atomic volume. What is the atomic volume? So what is atomic volume here? There are n hydrogen atoms are there. How many are there? N hydrogen atoms are there. 1 hydrogen atom volume is equal to V. So what is the atomic volume is equal to N into V. So we can substitute this value here, 6.023 into 10 to the power 23 into, what is the volume now here? 4 divided by 3 into pi into r cube. What is r value? 0.5 into 10 to the power minus 10 all cube. Right? Now you can see here, this is a constant value. Right? It's a constant value, Avogadro number. 4 by 3 pi. These all are the exact numbers. So which is the physical quantity? Here you can, what we are measuring here, that is 0.5. Radius is only one we are measuring here. In this measurement, you are taking the 3 times, 0.5 into 0.5 into 0.5. That means you are doing the multiplication. What is the significant figure rule in multiplication? Use the least significant figure. So which is the least significant figure here? 0.5. Only one significant figure should be in the final answer. Now you do the calculation here. Multiply this one and you get the final answer. You are getting this answer 3.154 into 10 to the power minus 7 meter cube. If you do the calculation, this value, okay, you are getting this value. But if you are writing this answer in correct significant figure, only how many significant figures should be there? Only one significant figure, right? So the answer is equal to 3 into 10 to the power minus 7 meter cube. So if the question is asking for write the answer in correct significant figure, only you have to write like this. Otherwise, what is your answer? 3.154 into 10 to the power minus 7 meter cube. Okay, so this is the atomic volume of 1 mole of hydrogen atom. Now let's discuss exercise question 2.17. So let's read the question 2.17. 1 mole of an ideal gas at standard temperature and pressure, that is STP, occupies 22.4 liter. In bracket it is given the molar volume. That means the molar volume is given, the molar volume is equal to 22.4 liter. 22.4 liter is given the molar volume. What is the ratio of molar volume to the atomic volume of 1 mole of hydrogen? That means you have to calculate here the ratio of molar volume to the atomic volume of hydrogen. Atomic volume of hydrogen. Atomic volume of hydrogen we have just calculated in the previous question. What is atomic volume of hydrogen atom? 3.154 into 10 to the power minus 7 meter cube. Let's check the previous question. So already discussed that one. So you can write here what is the molar volume. Molar volume is given the 22.4 liter, where 1 liter is equal to what? If you are converting into SI unit, 1 liter is equal to 10 to the power minus 3 meter cube. So you can write this value as 22.4 into 10 to the power minus 3 meter cube. So now it is molar volume we got now. Divided by what is the atomic volume of hydrogen? Atomic volume is 3.154 into, or we have written in the previous question nearly 3, right? Okay, you can write 3 also. 3.154 into 10 to the power minus 7 meter cube. So what is the final answer you are getting here? What is the final answer? Minus 7 minus 3. So if you take the minus 7 to the numerator, it becomes plus 7 minus 3 plus 4. So you can write here 10 to the power 4. Now 22.4 divided by 3.154. So you can see here it is approximately what? 22 and 7. 7 point something will come here. So the actual value is 7.1 into 10 to the power 4. So this is the ratio of molar volume to the atomic volume. Okay. So in this chapter there are many questions are there still. So please try all these questions. If you are not getting any questions, let me know. So I will be giving the lessons like this. Okay. So hope you understand all this question. Thank you all of you.